That's me with chopsticks. Sorry. Anyways, welcome everyone. And this is the last talk, so I won't take too long. Today, we're going to be learning about making apps adaptive with Compose and Material. Before doing that, let's just jump into a little bit about me. My name is Gurupreet Singh, and I'm a developer relation engineer at Google. And I also love both Compose and Material, and I'm currently working on both of them, so it's a really fortunate position for me. And I just like to make beautiful apps. I like to do a lot of open source as well, so I did this Compose cookbook, which is a collection of a lot of UIs for Compose, and the Compose for Spotify with the desktop versions, and font awesome icons to make even more beautiful apps. So that's all about me, not much to brag, so let's just jump into it. So before we make apps adaptive, so what is adaptive? Well, Instagram on iPad is the most adaptive. Not really. So when the UI for your app can account for screen sizes and responsive on taking that space, but also providing good user experience and navigation ergonomics. That makes a whole package of adaptive. But we've been making apps for so long. Why suddenly we need to care about making our apps adaptive? Well, now more than ever, there are so many devices running our apps. We have phones, tablets, foldable desktops running Android application. You do not know where user is consuming your application now. So that gives us a purpose to make sure that wherever our platform, our app is running, we make sure that it's adaptive. Before we make sure that we're making our apps adaptive, we want to know that what are the tools at our disposal that's helping us achieve that goal. So Android ecosystem is ever-evolving ecosystem, and it is growing for past 10 years. And with Android 12, it's completely redesigned for large screens. And it makes sure the whole user experience of the OS at the tablets or large screen is very cohesive. So if our apps is also supporting that, that would be a complete experience for a user. We have a resizable emulators and devices to test, foldable devices to test in Android Studio now. These gives us complete experience before we want to ship our application to production. And we have brand new large screen guidance and Play Store guidance to make sure our apps are adhering with those guidance to provide better user experience. Material design is also Google's brand new design system, which is giving more personalized and experience to user. Making design adaptable and accessible is core of it. It provides brand new guidance on material adaptive guidance, and it also gives complete new guidance on targeting foldable or flexible displays as well. Material also provides canonical layouts, which helps us think layouts in a new way. It provides us ready-to-use slot mechanism where we can think of different screen sizes placement and then target our device. So thinking that way, we can think of our layouts of an app in a way where we have a navigation area, we have app bar area, we have a body area. And all this area can be utilized and positioned differently depending on what we want to target, what size we have. And similarly, this body area can also further divide it into single pane area or dual pane area, or some call it like list area or detail area, depending on if we have available space. Now we know we have material guideline to process how we want to make our UIs, but let's see how our favorite Compose helps us. Compose is Google's official recommendation for making future of Android apps. So every app you're going to start right now, we recommend you to make in Compose. And Compose also, being declarative, provides very easy to make sure that we can adopt to large screens. So here we can see simply if we screen is large screen, we can go for grid layout and or list layout, other than making long codes or XMLs and dealing with them. Similarly, Compose being stateful, whenever the variable screen state changes here, it will re-render the whole screen and recompose in a way that we have the correct layout depending on whatever the screen size is. And Compose does not use XML, so we do not have to maintain large amount of XMLs and different screen sizes to keep it updating, which is growing with time. So quickly recapping that, we learned why we have adaptive, why Android ecosystem and Material and Compose is providing guidance on making your apps adaptive. Let's take a look at this reply sample. It's a brand new sample built with Compose, built with Material Design 3 guidelines to provide guidelines on how to make your apps adaptive. You can use it to make sure that some of the elements you use it in your current app, and it can take you to the next steps. Here we can see we have many different sizes target. We have tablet, we have desktop, we have small phone. And they use different kind of navigation as well. We have bottom navigation, navigation rail, and also it uses different amount of spacing for content. So before we know that all these screen sizes we jump into, we need to know what's our app sizes in those displays. Nowadays, we have multi-mode of our app running, so we do not know how much actually app space our app is taking. We are always getting the user configuration, device configuration to get the display size. To get this, we can leverage the power of Windows Manager, which provide us a window matrix calculator. If I'm running an app in a multi-mode in a tablet, I do not care how much the configuration size of a tablet is. I only care how much area my app is taking, and that's the most relevant to app developer itself. And here we can see it gives us both current window matrix and maximum window matrix. For our use case, we will just use the current window matrix, and it will give us how much app size area our app is taking. But now this is a very raw dimension that we are getting from this. It's just information of dimension, but we want to classify it in a way that we and a developer and designers can make sense of the UI and UX. So we can classify window size into both width and height classification. We can put this breakpoint in a way that we know that if our app isn't falling into these breakpoints, we can easily handle different kind of body structure and app content and navigation. So we can have a compact for 600 dp and below. We can have medium for 600 to 840 dp, and we have expanded if your device or tablet running in the area is more than that. We simply have similarly have window height classes also dividing into compact, medium, and expanded. But most of our applications actually is a scrollable content, so window height classes may not be that useful, and window width classes is where we actually take advantage of it. So let's just see how we can actually start observing this window size information in our applications. So we have this Material 3 window size library that you can use, and it gives a very simple composable function, calculate window size classes. And it gives you information both of width and height classes. And all you gotta do is just pass it to your app content, and you are ready to observe the information. But our content is need to react to this window size, so we think of the content as we previously saw in a way how we want to design it, how we want to react it. So we have a navigation area which can be different depending on the width or height. We have a body area which can be different depending on the width and height. So let's just see the navigation first. Material provides various suite of navigation. We have bottom navigation, we have navigation rail, navigation drawer, modal, or permanent as well for all different kind of situations. It's made to make sure that we target different navigation on different screen sizes that takes care automatically about user accessibility, reachability, and ergonomics. So now we know what kind of navigation we have. We have a window size coming to our application. So let's see how we can use that to select our navigation of our app. So we just declare a variable with navigation type, and which is bound to window width size classes, which is observing the real width size of the device. And if it's a compact, we want to choose for bottom navigation. If we have a medium, we want to choose for navigation rail. and we have a very expanded device or large tablets, we can leverage the permanent navigation drawer. Similarly, we can tie our content to this window size also. So we have both a single or dual pane area. So we can say we have a variable content type, which can be a single pane depending if it's a compact. And for medium, it can be single pane or dual pane depending on how much emphasis you want to put on your detail area. And for expanded, we can have a dual pane. So now we have a content type, we have a navigation type, which is tightly listening to the window size classes as the device goes through different states. We want to observe it in our content. So we passed both this variable to our content, and here we leverage the power of compose. We can simply say we put the navigation rail or permanent navigation drawer in a row fashion, and then if we want to put the navigation, bottom navigation bar, we can just put in the column fashion at below. And then we place our body content at the correct place where we want to place it and pass down the content type, which is also reacting to window sizes. So now to make our app's content dynamic, we can make sure that we put it in a row fashion where we know that our first items, the list items, are always visible. But if our content type is dual pane, we want to show the detail screen as well. We took these easy steps to make sure we have a different kind of navigation. We can have both single or dual pane depending on it. And it already enhances user experience on making apps for large screens. We can take even further step to targeting foldable as well. Foldables are a rising number of devices, and it comes in very different shapes and sizes, and it folds differently also. To make sense of all this thing, we need to understand some of the folding features first before we target foldables. So we have state, we have orientation, and occlusion and separating. So state tells us what is the state of the fold right now. It's half open, it's fully open. And orientation tells us the orientation, how the user is holding the fold. And it also tells the orientation of the crease or a connector if the fold has. Occlusion type helps us to know the area of the fold that's not accessible. If I folded it outside, the area behind is not visible to the user. We do not want to show UI there, even though it's part of app area. And separating tells us if there is a crease or connector that's actually joining two displays, and we need to take account for that. We do not want our apps clickable or touchable areas in a part where there's a connector or a hinge. So to make our app fold aware, we can use the window manager, and it gives us a info tracker API, which gives us the whole layout information of the device. This gives us the complete layout information on how the device state is, orientation is, and we can collect this information in real time and make a display features out of it, which are the folding features that we talked about, that it can be horizontal, vertical, half fold, semi-fold. But these features are still dimensions. We do not, we always have to classify it in a way so it's easy for designers and developers to work together to target this feature. So we can also classify fold into further some of the positions that is optimal for your apps. It's just some of the example, but you can even take more classification to whatever suits for your applications. Here we can see we can classify if the fold is flat or it's fully open. If it's in a book posture, if I'm holding fold like this, then it will be considered as a book portion. And if it's a tabletop portion, as shown in this graphic, how you want your UI to react, and if it's a separating where you have a connecting hinge to it. So let's just try to update our reply sample with this. So as we saw initially, we have window size, and we were passing it to content. Now we will sorry. So now we will, sorry for that. So now we will pass the device posture as well. Now our device, our app content is ready to listen both the window size and the device postures. So updating the navigation of it, if we know if we have a device in a book posture, we do not want our navigation drawer to reach to that book posture area. And that content should not overlap with that. So maybe instead of for expanded devices, we can use navigation rail. Similarly, this fold feature also provides us the hinge detections. So if we want to have a medium width, but we want to use book posture, we want to use dual pane if there's a book posture or separating, because we do not want some of the area that's underlaying a hinge or a crease. And some of the devices, like Windows Surface Duo, I think, have a very thick hinge. And we want to take account for that. So we can here see we have a list content. And if the device posture has a separating hinge, it gives us information about the hinge spacing as well. So we can put the hinge spacer. And here we are leveraging the power of compose. So we simply check if it's a dual pane. If we have a separating, we just put a hinge spacer between them. So these are a lot of things we are doing to make sure that our apps are ready for large screen, ready for foldables. But there are some early previews and improvements we are doing to make sure that it's even easier for us to adopt large screen and foldables. We have Accompanist Adaptive, which is a new, very early library that will help us make it easy to transition our app for large screen. Lastly, we saw this information where we were getting the display feature from Window Manager can be simply reduced to calculate display features in one line in your composable. So that gives you power and make sure that you are easily adopting inside your composable wherever you need it. It also gives information about dual pane UI, which is very similar to scaffold slotting-based API, where you can actually just call a composable to pane and provide it a first or second composable parameters, which takes the information. And here in our screen, it's email list and detail list. And it also provides us the strategy and display features. So if there's a foldable or some states, it can take care for you instead of us defining all the situations. We have both the horizontal and vertical pane strategy, and which even gives us more power to split our device UI in different fashions. So here we can see we do not want both the panes to divide equally. We can have 40-60 ratio. And if we have to add some spacing or gap between our dual panes, we can add that also. So this is Accompanist Adaptive has more and more features coming, so stay tuned for that. And it will make adopting the apps very easier for large screens. We have a very other cool API that says Moveable Content API. And here you can see in this screen, we have only thing changing here is the navigation. So we have a button navigation and the navigation rail in the side. So what happens is when navigation is always our top layer of the UI. So whenever there is changing, it may call recomposition down all the elements. And user may be scrolling, reading, or touching any of this. And we want to avoid users changing of the context. So what we can do is leverage the movable content and pass whatever our content we want persisted. So whenever there is a change on navigation, we do not want this content to change. So now if we have a navigation to navigation rail, or it's changing to button navigation, the app content inside will stay the same. This gives us very powerful on the performance and actually avoid a lot of recompositions down all the levels. So keep an eye on this API. We are further improving it and adding more features to it so it can be used a wide variety of the cases. All we did here, it also is leveraging towards improving the user experience and accessibility improvements as well. To improve even further, we can do small things that makes the user experience throughout the applications very nice. We can leverage the continuity, which makes sure that whenever a user is folding, unfolding its device, or extending its display, or stretching it in a desktop, the app stays in their state, and user is persistent throughout this. So to do that, we can take a couple of steps. We can use UI state flows with view models, which actually survives configuration changes, to make sure that our UI is as it is. If I'm reading an email here, it's just persisted if I fold or unfold a device. But there are some times we have to handle configuration changes because our devices is running in many different sizes and displays, so we want to make sure that we handle configuration changes also. If user is inputting some form or search, we want to persist that whenever user folding, unfolding a device, or stretching a display. Compose also provide a couple of API like remember and remember savable, which can help you to persist some of the information or scroll position and everything whenever user is changing its device state. We can further improve user experience by providing the ergonomics of device. Here we can see we have 3 points to put the action button. And if there are many devices and they may vary on different sizes, and user may use it for a very long time. So we want to put minimal strain on the users. We can put the button on first position, which is very highlighted, but user may have to expand his fingers to reach there. And we can also use the third button, which is actually mostly used and easy to tap also. But if there is a foldable or tablet with a very narrow bezels, it may misclick a lot. And here, in this scenario, we can choose position second, where it's easy to reach and may not happen all the misclicks. So these kind of things we can always keep in our mind while designing or developing our applications. Accessible design is really part of all the material components and the material design itself. It laid the foundation for all the material experience that we are providing. So here you can see the navigation rail component we used. It already provides 3 slots for all different kind of devices. So if we can also leverage now what we learn in window height classes to make sure that we use that to improve users' ergonomics. So if we have compact devices, we want to keep it top alignment. If it's a medium device, we want to keep in the center alignment. And for very large tablets, we can choose the bottom alignment for mostly used buttons. So these are small key features that actually improves the user experience a lot and provide them a good experience of your app, no matter which platform they are using. Just to recap some of the things we just learned is we learn about handling window sizes and how it improves our navigation and how we utilize the screen space in single or dual pane will just depending on our window size classes. We learn about fold features and fold classification as well, which can help us target more and more new foldables that's coming. We learn about the app continuity and how the ergonomics can help user experience overall. There's a lot of things we are improving for users on all these devices, but what are the other benefits of adaptive apps? Why you should care about it? So Play Store also provide good ranking and recommendation if you are targeting app for large screen. So if someone is opening your app for a large screen and it does not target that, Play Store give them kind of warning that, hey, your app, this app is not suitable for this device. It may have some glitch or something. So you always want to avoid that. It also provides very good user experience if user is switching for, let's just say, on a phone and just use the app on a tablet. It will be really nice experience to not just see the buttons and everything stretch. And improve user experience will actually improve ratings on large screen, which improves the overall app ratings as well. And there are 250 million plus large screen devices, and it's growing rapidly. So I don't know which product team would not want to ignore that. So it's always good to reach out to your product team and say, like, these are the reasons we can easily target, and these are the steps we can target adaptive skills. And we have Pixel Tablet, which is just announced yesterday, so I can share it. So it will open the space for new developers working on large screen apps, and it will actually onboard a lot of users on large tablets. So I think it's a very good time to make apps adaptive for you. The reply sample actually tries to cover a lot of cases where it's handling foldables, it's handling different screen sizes and tablets, and we are continuously improving it. You can get the sample here on the link, or you can check it in a composed sample. It's part of official samples. There are a lot of new resources to make sure you are learning good guidance for making your app for large screen. We have Material 3 completely adaptive guidance. We have a Compose adaptive code lab also available. And then we have this reply sample and a new guidance for Android 12 and above large screens. That's pretty much. Thank you very much, and have a great evening.